Hi guys, today we'll be going through tutorial 5 and it will still be kinematics. So we'll look at the harder type of questions, more on the free fall questions and vertical motion type of questions. Alright. Okay, let's look at question 1. Why does an object falling in Earth's gravitational field reaches a steady velocity? This occurs when your weight and your air resistance are the same. Okay, when that happens, your resultant force will be 0. Your acceleration will be 0. Okay, we will learn more about this in dynamics chapter when they talk about this thing called terminal velocity, conditions for terminal velocity, and what leads to terminal velocity. All right, so for this question, just remember it happens when your weight and air resistance are the same. So air resistance increases with increase of velocity. The Earth gravitational field decreases as the object falls. This is no. The mass of the object and the air resistance remain constant. Weight of the object never change. So answer should be D. All right, next. Free fall falls 3D. Free falling. Any of these terms just means free fall. When you see the word free fall, that means air resistance is not your acceleration. For object that's falling down, acceleration will be the same as that of will be acceleration due to gravity. So answer will be 10 meter per second square, and it never change. So answer will the acceleration is constant. A boy drops a ball from the top of the building. Drops a ball, that means your initial velocity must be 0. If the ball takes 4 seconds to drop to the floor, what is the final speed of the ball before it reaches the ground? So if you draw a velocity time graph, good practice to use, it will be like this. All right? This type of question usually is under free fall condition. So acceleration will be 10 meter per second square downwards. Since your object is falling down, the direction of motion and gravity is the same. So it'll be 10 meter per second. So 4 seconds, what is the V? So A equals to V minus U over T, then equals to V minus 0 over 4. Therefore, V equals to 40 meters per second. Answer D. Next. Okay, 3 and 4, we can use the same graph. And from 3, we found that the height, the velocity at the end of the 40 seconds is, the velocity at the end of 4 seconds is 40 meter per second squared. So area under the graph, half times base, 4 times height, 40. And you will get 80 meters. Answer is C. Next. Now you throw a ball, but it has initial speed of 5. So my speed time graph, you can no longer start from origin, but starts from 5. Again, A equals to V minus U over T. 10 equals to V minus 5 over 4. V is 45 meters per second. Therefore, answer is C. Same graph. Area under the graph. Half times 4. Wait, hold on. Let me see the question. Sorry. So half times base times height. But we can't do that anymore because now no longer triangle is a trapezium. So it's still 4, but now this is 5, right? Sum of parallel sides. 2 times 50. Answer is 100 meters. Answer B. Just now, the earlier question is drop. That means your object's motion or throw downwards, the object's direction or your object's motion is the same as gravity. Now it's opposite. Vertically upwards. And your gravity is downwards. So now, in this case, your acceleration will be minus 10 meters per second squared. Because the direction of motion opposes each other. Or rather, we take upwards to be positive, so anything downwards will be negative. So if you shoot the ball upwards, the initial speed cannot be 0. Okay, reach its highest point. At highest point, your velocity is always 0 meters per second. Okay, this is important. You need to know at highest point for any type of vertical motion, the velocity will be 0. The object, car, vehicle will pause for a short while. When you pause, your velocity is 0, then it falls downwards. Right? And in this case, your A will be minus 10 meters per second squared. So again, A equals to V minus U over T, minus 10 equals to 0, minus U over 2. Oh no, this is actually highest point. You don't even need to do this. Right? So at the highest point, your velocity is always 0, right? Because it pauses, then it comes down. So for this question, answer is A. Sorry, this is... Now for this question 7, the answer is Z. At highest point, velocity is always 0, so 0 meters per second. Next. Okay. For this type of vertical motion whereby the object is shot or thrown upwards, the acceleration throughout the entire motion is always 10 meters squared, 10 meter, 10 meter per second squared. So in this case, answer is option C. So if you recall the earlier question, A is minus 10. A is V minus U over T. Highest point, V is 0 meter per second. So minus 10 equals to 0 minus U over 2. So your U is 20 meters per second. But that's not the end. We're going to find the distance traveled. So for velocity time graph, distance traveled or the height achieved will always be area under the graph. Half times base times height. So it's then option A. So what this question is saying is can be represented graphically like this. You shoot something up, it reaches the highest point, then it comes down. So they're asking, this is t equals to 0. At what time will it reaches the ground again? Okay, 1, 2. So best you draw. Okay, so remember this height and this height is the same. So if I draw a speed time graph or velocity time graph, it look like this. This is 30. This one I don't know. But I know this is negative 10 meter per second square. Highest point, A equals to V minus U over T again. At highest point, your V is 0. Your A is minus 10. Therefore, your T is 3 seconds. So if I take 3 seconds to go up, I'll take 3 seconds to come down. So here will be 6. 3 plus 3. Right? It's the same as what I've drawn so far. It's the same as what I've drawn so far. The graph below shows how the velocity of the stone varied from the moment it was thrown vertically in air until it reaches the ground. So at this point, V is 0, highest point. Right? So therefore answer is next, calculate the maximum height. At maximum height, V is 0. So at t equals to 2 seconds, you have reaches maximum height or distance. So you find area under the graph for this portion. Hence it's half times 20 times 2, 20 meters. Okay, if you recall in the earlier lessons, velocity time graph gradient represent acceleration. From the graph, it can be seen that the gradient is constant. Therefore, the acceleration is constant. Straight line, uniform motion. Okay, we just use this point and this point to help us find. Of course, you also can use this point and this point. It doesn't matter because the gradient is constant. So A equals to V minus U over T. A, if I use these 2 points, 0 minus 20 over 2. So it's minus 10 meters. Okay, but you're asking for gradient, so it's just 10 meters. Okay, let's look at this. Release a stone. When you release, remember drops or release, your initial velocity is 0, starts from 0. 5 seconds to reach the ground. Okay, so this is a graph, basic graph you need to be able to draw. Sometimes it might not drop, it might throw. When throw, then usually the initial velocity will not be 0. So again, A equals to V minus U over T. A equals to, sorry. You're dropping something, your A is definitely 10. Unknown V minus 0 over 5. So your V is 50 meters. Okay. Right? Find the height of the building with the V and T. Area under the graph. That's how you get 125. Okay, so this is what? This is, I don't know anything. I don't have any values. Or rather, I have 5 seconds. Okay, release another stone. Greater mass. So this is 5. Well, let it be T. A equals to V minus 0 over T. So A equals to V over T.